Hello, everyone, and welcome to XDNA Basics for Genealogists, Finding and Confirming Connections. What is XDNA, and why do I care? I'm Roberta Estes. I normally write at DNAeXplained, my blog and my website, but today's presentation is brought to you by FamilyTreeDNA, the only testing company that includes the X chromosome. So what is XDNA, and why does it matter? XDNA has special properties. It's a special type of DNA that's beneficial to genealogists. Family Tree DNA provides free XDNA matching through the Family Finder test and on autosomal uploads from other vendors. Other vendors do include the X chromosome in their raw data file, but they don't include XDNA matching. XDNA has a unique inheritance path. XDNA isn't mitochondrial DNA, but those two are often confused. Mitochondrial DNA is inherited from your mother for both males and females, and it's your direct matrilineal line, meaning your mother's 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 mother, and it's only that line. So XDNA has a different but also a unique inheritance pattern that differs for males and females. The X chromosome is a hidden gem that a lot of people don't know about and don't know how to use. XDNA is part of chromosome 23, which is the sex selection chromosome. It's inherited differently for males and females. In this little chart, you can see that a male child inherits the Y chromosome from his father, which is what makes a male male, but inherits an X chromosome from his mother. So he only has one X chromosome. And the female child inherits an X chromosome from her father and an X chromosome from her mother. So she has an X chromosome from both parents and no Y chromosome. And that inheritance pattern can be a very useful key for you for genealogy. So the XDNA is included in autosomal tests, not utilized by other vendors, but it is at FamilyTreeDNA. So let's take a look at this female's X chromosome inheritance pattern. You can see at the bottom of the little fan chart here that we're dealing with a pink female tester here. And the females inherit an X from both parents. So she got an X from her blue father and an X from her pink mother. But males only inherit an X chromosome from their mother. So any male to male is a blocker. So the first thing you notice here in this diagram is that the her father couldn't inherit an X chromosome from his father, so he only got his mother's. So this portion of the tree of the female and tester's tree is completely blank because that X chromosome cannot be handed down to her. The same is true on her mother's side once you get to a male to male. So all of these portions of her tree cannot have contributed an X chromosome to her. The males who can contribute to her are shown in blue here, and the ancestors who cannot contribute an X chromosome are shown with no color at all. Moving now to the male chromosome inheritance path, we see that the male down here, he can't inherit any X from his father at all, so that entire part of his tree is completely blank. On the other hand, he does inherit his mother's, who inherited her father's, but the first male to male we have here is blocked. So his potential inheritance path of the X chromosome is much smaller. So males receive no X from their father, they only receive an X from their mother, and they only give their X to their daughters. So men do not give an X to their sons. So if you have an X match with a man, it has to be through his mother. And if you're a male, it's his mother and also through your mother. So that narrows down who can have contributed that X chromosome to you, to both of the testers. So let's take a look now at how X matches are evaluated differently. Due to the undivided inheritance in some generations, which means that because the male uh, received his mother's and it's not divided when he passes it to his daughter because he doesn't have anything to mix it with. The X tends to be older than other autosomes because it doesn't get divided in some generations. So it tends to hang on longer, reaching further back in time. The lower X SNP density, meaning the locations that are measurable per centimorgan, means that there's fewer SNPs per cm. So it is not only a smaller chromosome, it has less places to measure. So because of these unique characteristics, the X needs to have a larger centimorgan value to be equally as relevant. So let me translate this for you. It means that a 15 centimorgan match on the X chromosome approximately equals 7.5 centimeters on any other chromosome. So I wrote an article called X Chromosome Masterclass, and if you want more details, that's where you should look for some of the mathy parts of this. So let's take a look at what we're saying here. Normally, we have, well, not normally, we all have 16 great grandparents. And normally with autosomal DNA, they all contribute to our inheritance. But for XDNA, there's only 8 great great grandparents that inherit or can contribute an X chromosome, and only 5 for male. So there's much fewer opportunities for X matching. That also means there's a higher percentage of DNA per ancestor, though, that can be passed down because some of these are not recombined. Where there's a male, it's never recombined. It's not cut in half in that generation. So that means that there's more X matches in the same generation than autosomal, and there's more female matches because there's more opportunity. And if you're looking for the math, again, refer to the X chromosome masterclass. So there's special rules for the X magic powers. X is phased for males. Phasing means you know which parent contributed it. So immediately out the gate, you know it's from his mother's side. So if you have a male to male tester match, the X chromosome comes from both of the male's mothers. If you have a male and female tester match, it comes from his mother, and for her, it can come from either or both parents because it can be she can it could have come from her mother or father, so it can be recombined in her generation. For a female to female match, it can come from either or both of their parents. So it's phased for males, and anytime you hit a male, it's phased from their back in the tester's trees. So the X match is not necessarily from the same ancestor as the other shared segments, and it's not used in bucketing at FamilyTreeDNA. Now, for a long time, I made this assumption. And then when I actually started working these matches back in time, I discovered that every segment has its own history. So it's not just X matches that might come from different ancestors. If you have 2 different segments that you match someone on, one can come from one line, one can come from a different line, and the X could come from a completely separate line. Let's look at FamilyTreeDNA's X matching. You receive an X match only if it's paired with a FamilyTreeDNA autosomal match. That means that there are no X only matches. Why is that? Because you need a larger match to be a valid match with XDNA. It's displayed if the match is 10 centimorgans or greater on a single segment. So here we see for this person, for Patricia, this is my match. I match her at 115. For X matching, you'll never see less than 10. So you can link as many matches as possible. Even though X isn't used for bucketing, it will help you know where to look in your tree because it may come from the same ancestor as all the rest. And you can sort at FamilyTreeDNA by X matches. So what we have here This is your sorting and filtering, you can sort by XDNA, and here it shows you all of the people that match on the X chromosome. You can also download your match list and look in the XDNA column in that spreadsheet as well. So let's take a look at Patricia and my pedigree charts together. Now I know I've already done this work, so I know how we match, but how would I do this? How would I go about finding this? Well, the first thing is this on the left side is Patricia's pedigree chart here, the part that is actually relevant. So in Patricia's pedigree chart, I look at my pedigree chart, which is over here, and I've taken the two halves and kind of butted them up together so you can see them. For the match on Patricia's side to our common ancestor, which happens 3 generations back for both of us, is Curtis Benjamin Lohr and Nora Kirsch. And I found the most recent common ancestor, which is the gold star here for both of us. And here's our path back. So for her, it's through a father, through the mother, and for me, it's from the mother, the mother, the mother. But once we hit here, once we hit Curtis Benjamin and Nora, where could that come from? Well, there's only one place it can come from for both of us. If you look on my side of the tree, because I have a male here without Patricia involved, it could potentially come from any of these pink or blue. These are blockers, the no signs. But if you look at Patricia's tree here, the only part it can come from is the Joseph Hill to Barbara Milheimer group. So these are the common ancestors where that X chromosome had to originate. Now, how would we go about finding out who else it came from, who within that group? Well, we'd find somebody else that matches us on the X chromosome that descends from either Joseph or Nabby or Katharina or George or Barbara. And that would tell us, that would push the common ancestor and also the X chromosome origins back another generation. So that's what we do. We walk these segments back in time. So if we're looking at our pedigree charts, a normal autosomal match that's not an X could have descended from Curtis Benjamin Lohr, from Antoine, for his father Anthony, but it can't for X chromosome. Why is that? Because we have a male to male and it's a blocker. But so the X can't be male to male. So we know for autosomal it could be, but for X it can't be. So it has to be from this portion of the tree. So XDNA is resilient. It hangs on. It may reach back further, but that sometimes means it's harder to find in your tree because those ancestors may be further back. It doesn't recombine in every generation, and it does have a lower SNP density, but it may remain intact and unrecombine longer, so not divided. And it has the potential to reach back further in time to ancestors that don't share other um, DNA. So you may or may not be able to identify your common ancestor. Or you may be able to break down your brick wall. I have one at 7 generations where the ancestor was born about 1721 that I carry a 37 centimorgan X match with that person. And now from that ancestor. And now I know that anyone else who I match on that segment um, uh, on that who can match in that same part of my tree comes from that ancestor. And I have another one at 5 generations where the ancestor was born in 1790 that I share 53 centimorgans with. So if you're working with autosomal DNA, you'll recognize that these are very high centimorgan numbers for that far back in your tree. But that is the blessing of working with XDNA or one of them. So when the ancestor's a male, you get an automatic free space bingo jump to his maternal grandparents. So it's easier actually to track back in time because you can jump 2 generations at a time or hit a blocker, which narrows the potential candidates quickly for you. So, what is your XDNA path plan? Well, first of all, you want your DNA at FamilyTreeDNA. Either take a family finder or upload from 23andMe, Ancestry, or MyHeritage to FamilyTreeDNA. Um, when you can identify how you're related to someone, do that. Link them on your tree so that FamilyTreeDNA can use their algorithms for triangulation to bucket you with other people that you match on your maternal or paternal side. So link your known matches to your tree. Download your match spreadsheet. See how you match other people on that X chromosome and who you might match on your father's side, um, that's bucketed to your father's side and bucketed to your mother's side. Because if you can find one ancestor for that segment, you found that same ancestor among all of your matches for that segment on that parent's side. Evaluate each match using the XDNA template. You may discover multiple lines of descent, not just one ancestor, but the X may represent a different ancestor. Utilize additional tools such as surnames, shared matches, and the matrix. If you don't know about the matrix at FamilyTreeDNA, check out that tool because basically you can put anyone you want in the matrix and see how they match each other. So it's like clustering, but you create your own. Involve your family. Do your cousins carry XDNA that you don't, or your siblings? Because that may be helpful to you as well. They might have inherited a different segment that you didn't. That will be helpful to you in identifying your matches and your ancestors. So check your matches. Check who is waiting for you. See who you're an X match to, and see if you can figure out on your pedigree chart how you're related. What brick walls do you want to fall, and how can XDNA help you? If you have more questions, there are answers. On my blog, there's an articles and resources page. You can search for keywords. You can search for XDNA, and you can sign up for free email notifications when I publish about once a week. There's over 1,800 articles there for you now. And I hope you join me in unearthing your ancestors one gene at a time. Thank you so much.